Good afternoon, and a very special welcome to those of you who are just joining us. I am Peggy Nestor, a member of the conference planning team, and I am so pleased to announce our next speaker. For many of you, Doug Tallamy does not need any introduction, as he is widely recognized as quite the force for native habitat restoration. Today, Doug is joining us live from his southeast corner of Pennsylvania, where he is a researcher and professor of entomology at the University of Delaware. So he is also an author of several books, including the New York Times bestseller, Nature's Best Hope, and that happens to be the title of his program today. Now, a quick note that Doug will be available for Q&A afterwards, but we will not be doing that in this space, but instead, I would like for you to go to the water cooler and then you can meet with Doug there. So without further ado, we are so honored to welcome Doug Tallamy.
Thank you very much, Peggy. Pleasure to be here today. I want to talk to you about my idea of what nature's best hope is. But before I do that, I want to go back to last fall, not this fall, but what happened last year. All the red oaks got together and decided they'd make their acorns at the same time. That's called an oak mast, and this is what it looked like in a lot of places. Well, I'm easily entertained, so I took one of those acorns and I just stared at it, and I was rewarded because an insect started to chew its way out of that acorn. And it didn't take long. It chewed and it forced its way through its little hole, looked like the Pillsbury Doughboy, finally plopped down. And a very dangerous time for this larva because it tastes good. Lots of things want to eat it. So it's got to get to safety, and it does that by squirming a little bit more and goes right down underneath the ground in about 30 seconds, where it stretches in all directions, forms a chamber, and then converts to a pupa in that chamber, and then stays in that chamber for 2 full years before it comes out. And when it comes out, it is an acorn weevil. Now, weevils look like they have big noses, but that's actually an extension of the head capsule, and the mouth parts are way down here at the end of that extension. And if this is a female, she chews her a hole down into the center of the acorn, turns around, lays an egg in it, and that's how the acorn weevil gets into the acorn. Well, you might wonder why they spend 2 years underground. And the answer is that it takes acorns, red oak acorns, 18 months to complete their development. So if they came out the very next year, there wouldn't be enough acorns. That, of course, leaves a hole in the acorn, and a hole is a true vacuum. You know that nature abhors a vacuum. Well, there are actually 3 species of ants in the genus Temnothorax that like to live in the vacated holes made by acorn weevils. And if they find a fresh hole, what they want to do is move their colony from an old dilapidated acorn into it. So they get everybody working together. They're very excited. They're going to have a new house, and they carry all the babies and the eggs and the queen. And in about 30 minutes, they're inside. They post a guard at the hole, make sure nobody else comes in. And that's where they live for the next 2 years. Well, about this time, my wife says, "What is your point? What are you trying to tell us?" What I'm trying to tell you is that is just one of millions of specialized interactions that comprise nature. This is another one, the relationship between blue jays or jays of all kinds and oaks. Jays are the primary disperser of oak acorns. You're not going to have pileated woodpeckers breeding near you if you don't have lots of carpenter ants, because that is what they feed their young on. And you won't have carpenter ants unless you have lots of big trees that make those carpenter ants. You won't have this bee, Andrena facilii, unless you have Phacelia. That is the only plant whose pollen they can use to reproduce. As a matter of fact, pollen specialization is very common in our native bees. About 1/3 of our 4,000 species of native bees can only breed on the pollen of particular plants. About 12 species are only going to be found on perennial sunflowers, for example. You're not going to have Baltimore checker spot unless you have white turtlehead. Nature is really just a series of specialized relationships. Today, though, these relationships are in trouble. Nature itself is on the ropes. And it's on the ropes because we did not take Teddy Roosevelt's advice. Way back in 1908, Teddy heard that the state of Arizona was going to mine the Grand Canyon. So he went to the canyon, he looked out over the edge, and he said, "Leave it as it is." And with those 5 words, he started the process of forming the Grand Canyon National Park. The problem, of course, is that it's no longer possible to leave most of the country as it was. There's only about 5% of the lower 48 states, anything close to its original pristine ecological condition. And that's because we have logged the country repeatedly. We've tilled it, we've drained it, we've grazed it. We've got 770 million acres of rangeland, which is 4.5 times the size of Texas. Of course, we've paved it and otherwise developed it. We have straightened our rivers and dammed them, and you can spell that any way you want. We've polluted our skies and changed our climate for centuries to come. We have drained our aquifers and introduced more than 3,300 species of plants from other continents, many of which are running amok in our natural areas. In short, we have carved up the natural world into tiny remnants of its former self. And each one of those remnants is too small and too isolated from other remnants to sustain the species that run the ecosystems that support us. Why have we done that? Well, we thought that our nest, planet Earth, was so big we could foul it forever and there wouldn't be any consequences. But of course, we were wrong about that. And that's why we're seeing headlines like this, a pretty regular clip. The insect apocalypse is here. What does it mean for the rest of life on Earth? North America's lost 3 billion birds in the last 50 years. That's 1/3 of our North American bird population. And then there's this one. The UN predicts that we will lose 1 million species to extinction, possibly within the next 20 years. And I love the way they report it, just like it's another headline. I mean, they might as well say we're going to lose oxygen in the next 20 years and then just go on. It's not an option, folks. It is simply not an option. So I could go on about the pox that we humans have delivered upon our environments, thus upon all of our houses, but that is not what this talk is about. This talk is about a cure for that pox. It's a cure that'll take small efforts from lots of people, but those efforts will deliver enormous physical, psychological, and environmental benefits to everybody. Let's return to this headline briefly. The insect apocalypse is here. What does it mean for the rest of life on Earth? Well, E.O. Wilson, the great Edward O. Wilson from Harvard, probably the most famous entomologist, certainly alive today, maybe of all times. He told us what it would mean if we were to lose our insects. And he did that way back in 1987. He wrote this paper, The Little Things That Run the World. And he was talking about the fact that life as we know it depends on insects. And if insects were to disappear, lots of nasty things would happen, starting with the loss of our flowering plants. If we lost our flowering plants, that would change the physical structure, and not just the physical structure, but the energy flow that moves through our terrestrial habitats. I'm talking about the food webs that support our animals. They would all collapse, and we would lose our amphibians, our reptiles, our birds, and our mammals. The biosphere, the living portion of the earth, would rot because we would lost insect decomposers. We'd only have bacteria and fungi to do those jobs. And of course, humans would not survive any of those drastic changes. There's good news here, and that is none of that has to happen. We can save our insects, we can save our birds, we can save nature itself, but we're going to have to change the way we landscape in order to do that. Why is that? Well, let's just recall that humans are products of nature. We are totally dependent on nature. We're dependent on what we call ecosystem services produced by healthy ecosystems. What are some of the things that plants give us? They're pretty important, like the production of oxygen, clean water, carbon capture. Way too much carbon in the atmosphere. It's plants pulling it out of the atmosphere, fixing it in their tissues, and then pumping it into the ground. Plants build topsoil and hold it in place. They prevent floods, they dampen severe weather, and many other important things. What do animals do for plants? They provide pest control services. They pollinate nearly 90% of those flowering plants. They disperse plant seeds, and again, many other things. So designing landscapes like this that destroy the production of ecosystem services simply is no longer an option. It never was a good option. But today, with 7.8, 7.9 billion people on the planet, we need more ecosystem services than ever before. There were visionaries through the ages who recognized that we humans needed to work on our relationship with the earth. And Aldo Leopold was one of the most eloquent, wrote lots of things in the first half of the 1900s. And one of the things he said was, the oldest task in human history is to live on a piece of land without spoiling it. Now, there have been some indigenous groups who've been able to do that, but by and large, particularly our modern Western and Asian societies, we're terrible at it. We extract more from the earth than it has to offer, then we move to another place and spoil that as well. We're at the stage now where there's no other place to spoil. So Aldo had a dream that we would actually develop a land ethic. We did have to use the earth. We would farm it and lumber it and graze it and mine it and do all those things. But we needed to learn how to do those things gently and without destroying local ecosystems. That's what he labeled his land ethic, wrote about it in Sand County Almanac. What he never talked about, and I'm always wondered why, was developing a land ethic where we actually lived. And I'm not sure why that was, but I suspect that the notion that humans and nature cannot coexist in the same place at the same time was so deeply embedded in Aldo's culture, it's still embedded in our own, that he didn't even recognize it as an option. Well, what I want to argue this afternoon is that living with nature is an option. In fact, I'm going to argue it's the only viable option that is left to us today. You know, in the past, conservationists worked almost exclusively where there weren't a lot of people. We need to now flip that on its head. We need to save nature or recreate the natural world where there are a lot of people. Where are we going to start? Well, we can't ignore those pieces of private property because so much, at least in this country, is privately owned. 85.6% of the US east of the Mississippi is privately owned. If we ignored private property, we'd only be working on 15% of the land, not nearly enough to conserve what we need to conserve. There are also lots of areas we never consider for conservation efforts. But we need to start doing that. Things like power and pipeline rights of ways, 21 million acres. Power and pipeline rights of ways, railroad rights of ways, another 3 million, roadside rights of ways, 17 million acres. Golf courses, 2 million acres, airports, 3. You know, there's the Denver airport is twice the size of Manhattan. These are large places. Then we have all the places where we live, from rural areas to suburbia, and then even our cities, hundreds of millions of acres in those places. So if you add all that up, and you can think of other places that aren't on this list, that's 599 million acres that could be devoted to conservation that right now are not. How big is 599 million acres? Well, it's bigger than Vermont, plus New Jersey, plus Maine, Virginia, New York, Georgia, Florida, Oklahoma, Montana, California, plus Texas combined. Not having a place to do conservation is not the issue. We can do it almost anywhere. Well, conservation is probably the wrong word to use because we're talking about restoring nature where it's already been essentially removed. But even restoration is not right. People say you're never going to put it back exactly the way it was. And that's true. We're not. But it doesn't mean we can't reunite those specialized interactions, the players in those interactions, and create functional ecosystems, even if it's not exactly what was there beforehand. To do that, we have to start with the most important species, the backbone of ecosystems. Not all species contribute to ecosystem function equally, so we have to start with the ones that support other species. And the first thing you need to do when you're rebuilding an ecosystem is to establish a food web. Plants are capturing energy from the sun and turning it into food. Well, unless that food passes to animals, it's locked up in the plants and you don't have a food web. You don't have a functioning ecosystem. Well, it turns out most animals don't eat plants directly. They eat something that ate plants. And that something is typically insects. And most of those insects, it turns out, are caterpillars. Caterpillars transfer more energy from plants to other animals than any other type of plant eater. Here's an example. Carolina chickadee, we all think of them as seed eaters, but when they're reproducing, the babies can't eat seeds. They switch to insects, and most of those insects are caterpillars. And it turns out chickadees are not exceptions. 96% of our birds, of our terrestrial birds, rear their young on insects, and most of those insects are caterpillars. How do I know that? We actually have some data to support that statement now. This is a citizen science project that one of my grad students, Ashley Kennedy, did a few years ago. She put out a call for people to take pictures of birds during the breeding season when they were taking food to the nest. And she got thousands of pictures and reconstructed the nestling diet by identifying what was in the beaks of these birds for 20 families of common North American birds. The green bars are the percentage of those nestling diets that were caterpillars. And in 16 of the 20 bird families, caterpillars dominated the diet. So imagine what would happen if we took caterpillars out of the system. 16 out of the 20 common bird families would not be able to reproduce. So there's something special about caterpillars. What is it? There are actually several things special about caterpillars. The most obvious is that they're relatively soft prey items. If you think of this guy as a sausage with a very thin wrapper, the wrapper is the exoskeleton, the cuticle. It's undigestible. So birds don't want a lot of cuticle. And then it's wrapped around lots of good food. And because it's soft, you can stuff that prey item down the throat of your offspring without fear of injuring it. And if you ever watched a parent bird rear its young, they're pretty rough. They take that beak and just stuff it down there like a plunger. Caterpillars are also relatively large prey items. One medium-sized caterpillar is equal to the biomass of 200 aphids. Some of our birds do run around and catch aphids, but do you want to catch 200 aphids or get one caterpillar? They're nutritious. They're very high in fats, very high in protein. They have very low percentage of chitin, of exoskeleton, compared to many other insects, particularly beetles. Beetles are not like little sausages. They're like little tanks. Much of a beetle is undigestible, and they also have lots of sharp edges. And it turns out that caterpillars are the best source of carotenoids for birds during the breeding season. Now, I mentioned carotenoids not because I love organic chemistry, but because I'm a vertebrate. You're a vertebrate. Birds are vertebrates, and vertebrates cannot make their own carotenoids. We have to get them from plants. But we have to get them from plants because they are essential components of our diets. And that's why my wife, Cindy, makes sure I have a lot of carrots. So I get my beta carotene, and a lot of tomatoes. So I get my lycopene, and whatever that is. So I get my lutein. She makes sure I eat all those things because they stimulate my immune system. And I can't think of a better time to have a healthy immune system. Carotenoids are also antioxidants. They run around our body and protect our DNA from oxidative damage. They improve color vision. When your mother said, eat your carrots, you will see better, she was right. She didn't know she was right, but it turns out she was right. They improve sperm vitality, improve sexual attractiveness. Now we're talking about things like this male prothonotary warbler, who is bright yellow because he's had access to lots of luteins. And he takes those luteins and makes pigments out of them and puts them in his feathers. And the brighter yellow he is, the more ladies he attracts. But where are the birds getting their carotenoids from? From the prey items that they bring back to the nest. But as you can see, carotenoid levels are not equal among bird prey items. These first two bars here are types of caterpillars, far more carotenoids in caterpillars than any other type of prey item. Third bar is orthopteroids, things like crickets and grasshoppers and katydids. The adult caterpillars, the moths and butterflies themselves, are down here. Far fewer carotenoids because they're not eating green leaves. It's just the caterpillars eat green leaves. And here's the earthworm way over here. The early bird gets the worm, but he doesn't get any carotenoids when he gets the worm. Does this influence how birds choose the prey items that they bring to the nest? Well, Ashley did another study where she put GoPro cameras on the roofs of bluebird boxes, and those cameras took a picture once a second. And she had a lot of bluebird boxes and a lot of GoPro cameras, and she did it for 3 years. So she had, over 1 million pictures to go through. But the idea was to get good pictures of the birds as they were flying into the nest with a prey item. And she did. She got 7,628 usable observations where she could identify what was in the beak of the bluebird. And it turned out there is a good relationship between the amount of carotenoids in the prey item and how frequently they're brought back to the nest. Caterpillars more than anything else, followed by those orthopteroids, and then everybody else is nestled down here. So all this suggests that caterpillars are not optional parts of bird diets. It's looking like they are essential parts of bird diets. So let's just accept birds need caterpillars, particularly when they're breeding. The question, though, is how many caterpillars do they need? Is 1 or 2 enough? Well, if we go back to chickadees, got a lot of data on chickadees. How many caterpillars does it take to make a clutch of chickadees? Thousands, 6,000 to 9,000 caterpillars. 1 or 2 is not enough. And that's just to get them to the point where they leave the nest. After they leave the nest, the parents continue to feed them caterpillars another 24 days. So you're talking about thousands and thousands of caterpillars to make a clutch of a bird that's 1/3 of an ounce. These are tiny birds. And if you want them breeding in your yard, you need to make those caterpillars in your yard because they only forage about 50 meters from the nest. They're not flying 5 miles down the road to the nearest woodlot. So when we landscape in a way that does not make enough caterpillars, that's called insect decline. And it's starting to look like it's one of the major causes of bird declines. Why do I say that? Well, we looked at the data from Rosenberg et al. They were the group that said we had lost 3 billion birds in the last 50 years. And you could divide the birds up into 2 groups. The species that require insects, at least at one part of their life history, usually breeding, and the species that don't require insects. The finches and the doves and the crossbills, they can reproduce on milk made from seeds. They actually gained a little bit in the last 50 years. But the birds that require insects lost on average 10 million individuals per species. This doesn't prove cause and effect, but it certainly suggests there is a strong relationship between declining insects and declining birds. So if looking for a solution, one could be we need to landscape in a way that makes caterpillars. Different goal from the way we've landscaped in the past, but probably a worthy goal. How do we add caterpillars to landscapes? We do that by adding the plants that make those caterpillars, but there is a catch, and that is most plants don't make a lot of caterpillars. So we have to figure out which ones do and make sure they are in our landscapes. Why don't most plants make caterpillars? Well, insects, particularly caterpillars, are really fussy about which plants they eat. Most caterpillars are what we call host plant specialists, like the monarch butterfly here, only going to eat milkweed. So you have to have the plants on which the caterpillars have specialized. Why do we have so many insects that are specializing on plants? Well, we have host plant specialists because plants have made them that way. Plants don't want to be eaten. They want to capture the energy from the sun and use it for their own growth and reproduction. So they've loaded their leaves with nasty tasting chemicals, secondary metabolic compounds that make those leaves either bitter or downright toxic. And it's a really effective defense. It keeps most of the insects of the world from eating most of the plants of the world. And that's why it's green out there, at least in the summertime. It's not because there's no insects out there that want to eat those plants. It's because most of the insects that are out there cannot eat those plants. And if you don't believe me, next time you see a green leaf, eat it. See if you like it. You're not going to like it. All plants protect themselves chemically. There's a reason it is hard to get our kids to eat their vegetables. They inherently know they're toxic. That's my little joke. This is not a joke. Insects do eat plants. So how do they do that? How do they get around those chemical defenses? Well, this is where the specialization comes in. Most insects can only eat a few types of plants that they have developed the adaptations necessary to get around those chemical defenses. The specialized enzymes and behavioral adaptations and life history adaptations that allow them to eat those plants without dying. But they can't do that for all plants, so they pick one or two plant lineages that have a common type of defense, and they get good at getting around those, but they can't eat any others. And it takes them a long period of exposure to those plant lineages for all those adaptations to fall into place. It does not happen overnight. All I'm trying to say here is that plant choice matters. If we're trying to reestablish food webs where they've been destroyed, we have to choose the plants that will support those food webs. Choosing the wrong plants isn't going to do it. And I'm going to give you 3 examples of how well that can work. I'm going to start with our house right here in Oxford, Pennsylvania. I am sitting in that window right now. This was a farm that was broken up. 10 acres. We got 10 acres. Nice piece of property, but it was an exhausted farm. It had been farmed for nearly, believe it or not, 300 years. And the last bit of farming they did before they sold the place was mowed for hay. But at that point, the land was thoroughly invaded with Asian ornamentals, and mowing for hay in this part of the world is really mowing for, they chop up autumn olive and multiflora rose and they call it hay. Well, of course, it was out of mowing before we moved in. And during that time, the rootstocks of all those things were mowing returned. So our 10 acres looked like this. This is Oriental bittersweet and Japanese honeysuckle and multiflora rose, all those things. That's my wife, Cindy, going to get rid of all this stuff on our 10 acres. If you're depressed by your invasive challenge on your property, it is depressing. But Cindy could do it. You can do it. What was I doing while she was working hard getting rid of all these things? I was congratulating her, telling her she was doing an excellent job. But I also was putting plants back, and I did it selfishly. I wanted to put plants back that I hoped would attract caterpillars to our yard that I wanted to take a picture of, my little hobby. And this is an example. I wanted to bring the Canadian owlet to our property, but in order to do that, that's what the adult looks like, by the way, I needed meadow row. That's the only plant they eat. We didn't have any meadow row. I'm sure it was here hundreds of years ago, but it's sure not here now after all the abuse the land has taken. No meadow row anywhere around us. So I got some meadow row seeds from somebody, planted them. They grew very nicely, but I didn't know how long it would take Canadian outlets, if ever, to find my meadow row. So I didn't bother to check it. Well, after a month and a half, I did walk by and I noticed it was almost defoliated. It had attracted Canadian owlets right away. I have no idea where they came from. And now we have a healthy population of Canadian owlets and Meadow Row. There we go. We've added 2 species to a depauperate landscape. Same story here. Wanted the goldenrod stowaway. Why? Because I think it's a pretty moth. It's a specialist on this plant. Has nothing to do with goldenrod, by the way. That's a misnomer. Biden's aristosa, ditch daisy. I did know where there was some ditch daisy about 14 miles away in a power line cut. I got some seeds, planted them. They grew really nicely. And it took about a year for the goldenrod stowaway to find it, but it has found it. And we've got a good population of both. So now we've added 4 species. I wanted the Hackberry Emperor. It's a butterfly that ought to be in our yard. That's where, this is where it belongs. But like its name implies, it's a specialist on hackberry, and we didn't have any. So I planted hackberry. We waited 3 years, 4 years before finally the butterflies found us, but now we've got a good population of both. Did not plant goldenrod. It came in on its own, and along with it came many of the things that eat goldenrod. There are 110 species of caterpillars that eat goldenrod in this neck of the woods, like the brown-hooded owlet, the Arcigera flower moth, the goldenrod leaf miner, the distinct Sparaginothus, goldenrod gall moth, goldenrod flower moth. And this is one that has not come to our property, not yet. This is anticipation. That's what the caterpillars look like. So it's like waiting for the ketchup to come out of the bottle. Every year I go out and check my goldenrod and see if it's here yet. Not yet, but it will be, and that'll be a great day. Same reason I planted Virginia creeper. People don't like Virginia creeper. I don't know why. It's a beautiful plant, and it supports lots of life. Things like the Pandora sphinx and its beautiful adult, the lettered sphinx, the hog sphinx, abbot sphinx, very powerful plant, particularly for sphinx moths. I wanted the zebra swallowtail because I think it's the prettiest one of our swallowtails. I like beauty like anybody else, but it's a pawpaw specialist. Now I was pushing it here because we are at the northern limit of pawpaw and zebra swallowtail. Actually, we're above it. Nearest one I know of is 26 miles south of us along the Susquehanna River. So I didn't know if they'd ever find our pawpaw. We planted it. We did have to wait 9 years, but we did eventually attract the zebra swallowtail. Now we have a good population of them. In the meantime, we got the pawpaw sphinx. I didn't know there was a pawpaw sphinx. And we got lots of pawpaws. Wanted the double-toothed prominent because it's a cool-looking caterpillar. It's a specialist on elm, so we planted American elm. Wanted the evening primrose. Again, a beautiful moth. Well, it's easy. You plant evening primrose, and it spends the day in the flowers of the evening primrose. Very cute. We also planted lots of oaks. Now, those are just examples of the plants we put back in our yard. But I want to focus on oaks because it's such an important plant. This is the Bedford oak in Bedford, New York. People argue about whether it's 400 years old or 500 years old. It's enormous. And a lot of people think you need enormous old oaks before they can contribute to your landscape. I hear all the time, I'm not going to plant an oak because I won't live long enough to enjoy it. Well, unless you die before the next year, I challenge that. You can enjoy it. And I say that because I planted my oaks, most of them from acorns or from 2-foot bare root whips. And right away, they started to attract the things that use oak, things like the solitary oak leaf miner, juvenile's dusky wing, the yellow-shouldered moth, the orange-headed epicalema, red-washed caterpillar, the yellow-vested moth, the orange-tufted oneida, the spiny oak caterpillar, the 2-spotted oak punky, the variable oak leaf caterpillar, the red-humped oak worm, the orange-humped oak worm, the pink-striped oak worm, the delightful dagger moth, the pleasant dagger moth, the lesser oak dagger moth, the greater oak dagger moth, the streaked dagger moth, the afflicted dagger moth, the crown bucolatrix, the white blotch heterocampa, the oblique heterocampa, the red line panapoda, the laugher, and literally hundreds more have come to our oaks, and they come right away. This is a pin oak that has just popped its head above the leaf surface. And here is a crocus geometer standing on the ground eating those leaves, even though it's a tiny tree. So your oaks start to contribute to your local food web almost immediately. This is a picture of our house from the same place I took that first picture. I took this a few years ago, but it's just to illustrate that we've put the plants back. Not all of them, still working on it. But I noticed right away, look, we've got some lawn. We're very traditional here. Noticed right away that moths started to come to our house. And I want to take a picture of every species of moth that has colonized all the new plantings that we put in. I made it a goal starting 4 years ago to take pictures of that, and I'm still at it. But just yesterday, I added the 1,000th 1,022nd species of moths. We got 1,022 species of moths on our property. Now that's just moths. That's not butterflies. Haven't started to count them yet. That's 1,022 species of bird food. Remember, we have 10 acres. Pennsylvania is 2.4 million acres. So on 1/240,000th of the land area, we have 40% of all the moth species that occur in Pennsylvania. And because we've got all of those species of bird food, we've recorded 59 species of birds that have bred on our 10 acre. That is 38% of all the birds that breed in Pennsylvania. So it can happen on a fairly small property. What was it? 2 weeks ago, we saw this headline: 2/3 of wildlife has vanished from Earth since 1970. All I can say is not at our house. I'm willing to wager that we have increased wildlife by 2/3 at our house, at least 2/3 since we moved in. So I offer this as encouragement. These are depressing headlines, but don't let them depressing. Get busy. We can turn this around. We can restore food webs and rebuild that wildlife if we put the right plants back. But I know what you're thinking. We've got 10 acres and you just have a little suburban lot. Can it work in suburbia? That's a good question. Let's go to Margie and Dan Terpstra's house in Kirkwood, Missouri. I visited there just before the virus broke out. They're in a very typical development. They're surrounded by people with big lawns. They only have 0.6 acres, a little bit more than half an acre. So about 18 times less land than what Cindy and I have in Pennsylvania. Their major invasive species was bush honeysuckle, and they got rid of that. And then they planted native plants, put in a bubbler, little water feature they call a bubbler for their birds. And then they sat back and started to count the birds that have used their yard. And they're up to 149 bird species. That's 30 and plus 35 warbler species. We've only had 8 warbler species. So, and that's on 18 times less land. Does it work on smaller properties? Yes. Just put the plants back. What about urban yards? Let's go to Pam Carlson's house in Chicago. And I mean in Chicago. Because she lives right next to one of the runways of O'Hare Airport, right next to Kennedy Expressway. She has 1/10 of an acre. 3 times smaller than the average lot size in North America. And no connectivity at all. She's not connected to any type of a wild space. So she's an island. But she got rid of her invasive species, put in 60 species of plants, again, a water feature, and she started to count her birds. She's up to 116 species of birds that have used her yard, including a woodcock. There's Pam's woodcock right there. If you haven't seen a woodcock lately, go to Pam's house. What about city centers, though? 82% of North Americans now live in cities. What are we going to do about them? Well, in 2014, I was staring at this plant. This is Asclepias tuberosa. People call it butterfly weed, but that reminds me, we have a serious marketing issue with our native plants. We call them weeds and then wonder why people don't plant them. So we're not going to call this butterfly weeds anymore. We're going to call it Monarch's Delight. I was staring at Monarch's Delight in 2014, and right away I saw 2 species of leafcutter bee, megachilid bees. I know they're leafcutter bees because they collect their pollen on their tummy, not on their legs. Well, leafcutter bees have very specific requirements. Not only do they need pollen and nectar, but they also need soft leaves because they cut out the edges of those leaves, roll them up, and stuff pollen into them, and that's where they lay their eggs. And they put the whole tube into a crack or a crevice. Well, redbud is a perfect type of soft leaves, and there was a redbud right next to Monarch's Delight. So the megachilids, the leafcutter bees had everything they needed. And because there was a redbud there, it blooms early in the spring, so did the bumblebees. Bumblebee's most challenging time of the year is right away in the spring because it's only the queen. She has to have very efficient foraging so that she has enough energy to start her colony. There are no workers to go out and do it. She's got to do it all. And early big blooms of redbud is a great way for her to start. And there were bumblebees there. Then I saw a monarch. Actually saw 2 monarchs on Monarch's Delight. Now this was 2014. 2013 was the low point of the monarch population. They were down to 3.6% of their 1976 population. So, really looking bad for monarchs. I had gone all 2013 without seeing any monarchs at all. And here it was. This was June, by the way. It's rare for monarchs to get up the East Coast this far north in June. And so I'm really happy. I was impressed. Here are monarchs. They're there. That not only was there monarch delight, but there was also another species of milkweed. So they had what they needed. Not only did they have nectar, but they had the host plant. They could start a population. Do you know where I was? I was on the High Line in the middle of Manhattan. The High Line's an elevated railroad that it was abandoned, and somebody said, let's make it a tourist destination. They went up, and there were a lot of native plants growing naturally up there. Nobody had planted them. So they enhanced those plantings. It's now a major tourist destination. Literally millions of people go to the High Line to have fun with this little bit of nature. It's just this strip here, 30 feet above the taxis and everything else, right in the middle of all the construction. This is Rick Darke. He wanted me to see the great plantings along the High Line for years. I'm not much of a city boy, but finally he dragged me there. And, I figured I'll see pretty plants, but there won't be anything on them. I mean, let's face it, the middle of Manhattan, how are they going to find it? I was totally wrong. And it convinced me that if thoughtful native plantings, and by the way, the High Line is not 100% native, but most of it is. If thoughtful native plantings can bring this much life back to the middle of Manhattan, we can do this anywhere. Somebody's surveying the bees now on the High Line. There are up to 30 species of bees that have found it. This will work anywhere. But there are 4 things we need to consider if we're going to succeed. And the first one is we have to reduce the amount of lawn that we have in this country. We have 40 million acres of lawn. And it looks like this. And lawn is a dead space. I mean, it's a status symbol. I get it. We can be high quality high quality citizens if we take care of our lawn. But 40 million acres, that's the size of New England that we've taken out of ecosystem production. Let's cut that in half. Let's take half of our lawn out of lawn and put in the plants that are going to support local food jobs. Now, the lawn we keep will still be manicured. We will still be good citizens. We will not be thrown out of our neighborhood. It'll be okay. But if we replant half the area that's in lawn, that gives us 20 million acres to put towards conservation. And if we do this at home, we can build what I'm calling Homegrown National Park. It'll be bigger than the Adirondacks, plus Yellowstone, plus Yosemite, Grand Tetons, Canyonlands, Mount Rainier, North Cascades, Badlands National Park, Olympic National Park, Sequoia National Park, plus the Grand Canyon, plus Denali, which is huge, plus the Great Smoky Mountains. Add up all those parks, still less than 20 million acres. There are real benefits to building your own park right where you live. And one of the most important one is you get to establish for the first time or reestablish a relationship with the natural world. Lots of health benefits from doing that. We don't have time to go into, but you also get to do it at your own pace, your own time, whenever you can. You can avoid crowds. It's important to avoid crowds. You can't develop this relationship in a crowded space. If you go to a real national park, there are millions of people there. It's free, no admission. It's never closed, no matter what pandemic comes down the pike. No travel hassles, and you can experience that natural world alone. This is particularly important for our kids. They can get rid of their nature deficit disorder if they get to go outside. No parental supervision, just deal with the natural world in your yard and see what it's like. Maybe they can learn how to hunt lizards. I'm learning this from my own granddaughter, Zoe, who lives in Hawaii, and her patch of nature is pretty small. It's not all that natural either. It's lawn and a hedge, about 10 square feet of it. But with that little space, there are also anole lizards there. So she has figured out how to hunt them. This is how you do it. You get on the ground and you disguise yourself with leaves and sticks so the lizards don't see you coming. And you crawl very slowly towards the lizards. No smiling. This is serious business. You can wear your best dress, that's okay. But then you sneak up on the lizard and you grab them and you put them in an aquarium and you have a personal relationship with some part of nature. Now, I don't think Zoe's going to be crawling on the ground covered with sticks for the rest of her life, crawling after lizards. But I do think she will remember this experience that she had when she was a little girl for the rest of her life. If you want to learn about other ideas of how to play with nature at home, get this book by Nancy Stranisti, Nature Play at Home. Hundreds of ideas of what kids can do in very small spaces. All right, we're going to shrink the lawn. What are we going to put in the area we take out of the lawn? We're going to put what I call keystone plants. At least some of them have to be keystone plants. It turns out that not all of our native plants are equal in their ability to support the life around us. A few are really, really good, and most of them are not doing that much. Only 5% of our native plants are making about 75% of the caterpillar food that drives our food webs. 14% of our native plants are making 90% of the caterpillar food, which means 85% of our native plants aren't doing all that much. So the question is no longer simply are natives better than non-natives? On average, they certainly are. But the question really is, do we want ecologically productive plants in our landscape? Or benign plants, or even worse, ecologically destructive plants? We put in the calorie pears and the burning bush and the barberry and all those things that escape and then biologically pollute our natural areas. I get an email once or twice a year from somebody who says, don't I know that ginkgos, Ginkgo biloba, actually grew in North America 7 million years ago? I mean, that's an ornamental from Asia right now. Grew in North America 7 million years ago. That makes them native, according to these emails. Therefore, we can plant them and everything will be great. This is not our metric. It's not whether they're native or not. It's whether they're productive or not. I don't care if ginkgos grew on the moon 7 million years ago. They produce 0 species of caterpillars. If you want to support the life around you, ginkgo's not going to do it. What is going to do it? Well, oaks are the #1 genus of plants in this country in terms of supporting food webs. 557 species of caterpillars in the mid-Atlantic states, right next to Ohio, which has a similar number. Over 900 species nationwide. Each one of these is a species of bird food. There is no other plant genus that comes close to oaks in terms of its productivity. And I'm going to give you an example of what oaks are doing at our house. Remember, I've taken pictures of 1,022 moss species. Out of those 1,022 moss species, I know what 898 of them are eating. I know what their host plants are. So there's a bunch I don't know what they eat. Nobody does. But out of the 898 species, 265 species use oaks. Now we have 68 genera of native woody plants on our property, only one of which is the genus Quercus, the oaks. And we have hundreds of genera of herbaceous plants. So oaks represent less than 1.5% of our woody plant diversity and way less than 1% of our total plant diversity. But they support almost 30% of our moth species diversity. That's what a keystone plant does. Imagine what would happen to the diversity of life at our house if we took oaks away. How do you know what the keystone plants are where you live? You go to Native Plant Finder in the National Wildlife Federation website, put in your zip code, and the ranked list of both woody and herbaceous plants will pop up for your county. It'll look something like this. I mean, I stopped because I ran out of room. Notice I say native oaks, native cherries, native willows, native. You can go to the nursery, and if you say, I want a cherry, they're going to send you an Asian one. If you say, I want a willow, they'll sell you a weeping willow from the Middle East. You can even say, I want an oak, and chances are you'll get a Chinese oak or an English oak. Specify you want native species of these genera. Because if you don't, we've done this experiment. Even though these are native genera, if you put in non-native members, you will reduce caterpillar use by 68%. Here are the top herbaceous plant genera in most of the counties, particularly in the east. Goldenrod's very high, native aster is very high, sunflowers very high. And with those 3 genera alone, not only are you making lots of caterpillars, you're also making, you're supplying the pollen for at least 40 species of native bees that are specializing on the pollen of these 3 genera. So if you don't have those in your yard, you've just lost 40 species of native bees. Okay, we're going to shrink the lawn. And then we're going to put in these powerhouse plants, and they'll bring lots of caterpillars and moths to our yard, and then we're going to kill them all with our security light. Of course, that is not the goal. Keystone plants only work where you don't have a lot of light pollution on at night. Light pollution, and a lot of this research comes from Europe, but it's turning out to be one of the major causes of global insect declines. Insects die at lights because of exhaustion. They fly around till they're exhausted. They collide with the light, they get incinerated, they die from dehydration. The bat comes and eats them. Many of the nocturnal insects are blinded by lights. and it wrecks what they're about. I mean, they're supposed to be mating and reproducing and foraging, but instead they're sitting at a light. This is actually good news to me because correcting light pollution is easy. It's the easiest thing we can do. All you have to do is turn out your light. But I know what you're going to say. You can't turn out your light because if you do, the bad man will come. Okay, put a motion sensor on your light, and then it'll only turn on when the bad man does come. And the first thing you're going to find out is the bad man doesn't come very often. If you don't want to do that, take the white bulb out of your security light, and mercury vapor lamps are the very worst, and put in a yellow bulb, one that throws yellow wavelengths because they are far less attractive to insects. And a yellow LED light is the least attractive. If we were to replace all of our night lights with yellow LED lights, we would save billions of insects overnight and a whole lot of energy. It's a no-brainer. Fourth thing we need to do is to landscape in a way that allows caterpillars to complete their development. What do I mean by that? Well, I live in Chester County, Pennsylvania, that's southeast Pennsylvania, where oaks support 511 species of caterpillars in that single county. A few of them, like the polyphemus moth, complete their development on the tree. The caterpillar eats the leaves, then it spins a cocoon and hangs from the branch. Then the moth emerges and it does it all again. Everything happens on the tree. I wish everything did that. But most don't. 480 species, 94% of the things that eat oaks drop from the tree when they finish growing as caterpillars and wiggle beneath the ground to pupate underground, or they spin a cocoon in the leaf litter. Well, you see what the problem is here. We don't have any leaf litter under the trees, and we mow everything and compact the soil to the point where it's too hard for the caterpillar to wiggle underground. And then this becomes an ecological trap. We call in those moths to lay their eggs, the caterpillars develop, then they drop down and die. And the next generation is smaller, and the next generation probably disappears altogether. I am willing to wager, the research has not been done, but I'm willing to wager that this type of landscaping is one of the major causes of insect declines wherever we landscape like this, which is everywhere. And of course, the cement landscape is even less of a viable option for caterpillars. I'm not trying to discourage the use of trees in cities. I'm trying to discourage the use of cement as a default landscape. That's just laziness. We know that destroys watersheds. There are many better ways to do this. This is what most people do. You have a tree in the middle of a big lawn. Nobody has studied the survivorship of caterpillars in a situation like this, but I guarantee it's higher in a situation like this, where you have a tree, then you have a layered landscape. You might have a dogwood over here, and then a native azalea, and then ferns and the ground cover. The caterpillar falls down. It can easily wiggle beneath the ground because the soil's all nice and loose, or spin a cocoon in the leaf litter under here. It's a safe site. Do your spring ephemeral gardening next to your trees. You get that dappled shade. This is the way you shrink your lawn. Don't have the grass go right up to the tree. Have big broad beds around the base of your tree, and all of a sudden you have less lawn, and you've created a lot of safe sites for those caterpillars. This is where you put in your ground covers, your wild ginger like you have here, or native pachysandra, or May apples, or foam flowers, and many other choices. All safe sites for those caterpillars. Another grad student, Desiree Narango, has demonstrated that there is room for compromise in our plant choices, and that's good news. She studied chickadee reproduction in the suburbs of Washington, D.C., typical suburban yards. And she compared what happens to chickadees when they're trying to reproduce in a yard that's dominated by native plants versus a yard dominated by typical Asian introduced plants. And the first thing she found is that when they're dominated by introduced plants, they produce 75% fewer caterpillars. So right away, there's 75% less bird food. Those landscapes were 60% less likely to have breeding chickadees at all. There are nest boxes there. The chickadees came, looked around, and said, there's not enough food though. We're not even going to try. If they did try, those nests contained 1.5 fewer eggs. They were 29% less likely to produce babies at all. If they did produce babies, it was 1.2 fewer fledglings, and it took them 1.5 days longer to do that. You might say, well, those aren't huge differences. You put all that together in a population growth model. This is what it looks like as a function of the percentage of non-native plant biomass in your yard, from none to 100%. This dotted line is replacement rate. This is the rate at which the population needs to reproduce if they're going to replace the adults that die every year. If you reproduce at this rate, you've got a sustainable population. It's not growing, but it's not shrinking either. If you make more babies than adults die, you've got a growing population, but if you make fewer, you've got a shrinking population. And right here is where those lines overlap or intersect, right around 30% of the plant biomass in your yard non-native. As soon as you exceed 30% non-native plants, you're down into this unsustainable, excuse me, unsustainable land for breeding birds. So this actually is good news to me for two reasons. It is the first time this has been measured for any bird anywhere. So anybody who doubts that your plant choices actually influence, seriously influence the things that are trying to live in your yard, take a look at this study. But here's the area of compromise that I was talking about. You can have up to 30% of your plant biomass non-native, and you can still have successful reproduction of birds in your yard. You can have your ginkgo tree. You can have your crepe myrtle. No invasive species. That's not allowed because they're not going to stay in your yard. That's like releasing smallpox spores. We're just not going to allow that. But you can have your hostas. I mean, it'll be great. You can have those pretty plants that you love as long as they don't exceed 30% of your total plant biomass. Can native plants be used in formal designs? Of course they can. Here's a formal landscape where they're replacing the typical plantings with native plants. Here's Joe Pye. Notice I didn't call it Joe Pye weed. And the goal is to replace all of these plants with native plants. Formality is a function of the design. It's not a function of the plants in the design. Our native plants are used in formal designs in Europe all the time. And I guess that's okay because they're non-native plants over there. Can we get a pollinator garden into a typical suburban yard like this that otherwise is absolutely dead without offending anybody? Of course we can. Put a little fence around it. All of a sudden it's great. You got beautiful blooms here. It will service lots of different types of bees. And if everybody did it, we would really increase our bee populations, which is important. Our bees are declining, and people say, well, that's a problem because they help our agriculture. Yeah, but that's not the real reason. Remember, our bees are pollinating 80% of all plants and 90% of all flowering plants. A lot of people think if you don't live near agriculture, you don't need pollinators, but you do, because we need them every place we need plants, which is every place. That means including our yards. How about this design by Drew Latham? It's bigger. You can accommodate lots more pollinators. Imagine the life that is here versus the life that is here. And nobody's going to object to this, really. In my view, we've made three missteps in the early years of conservation, the early years being last century. And the first is that, we've assumed that nature is important. We like nature. We like it, but it's not essential. It's not essential. So when resources are short, which is they always are, push comes to shove, nature loses. We've demonstrated that over and over and over again. I was at the Cincinnati Zoo, the Cincinnati Zoo, wall-sized poster. This was before the virus, saying save wildlife for future generations. This is the dominant view of what conservation is all about, even among our top conservation biologists. We need to save it so the future generations can know what a cheetah was and enjoy the natural world. And that is so true. But that suggests to me that nature is there just for entertainment. It is a lot more than that. We need to save nature so that we have future generations, a little bit more urgent. Number two, we've assumed that humans and nature cannot coexist. Now, we talked about this. If we restrict conservation efforts just to the areas of the planet where there are no humans or very few, we've condemned them to failure because those places are too small and they're too isolated to sustain the species that we need them to sustain for very long. David Quammen has an excellent analogy between a Persian rug and an ecosystem. This is a functional Persian rug. That is not 71 Persian rugs. That is 71 Persian rug fragments, none of which are acting like a Persian rug. And that's what we've done to our ecosystems. The UN designates biosphere reserves as places of ecological significance. And I hate that terminology because it suggests there are places on planet Earth that have no ecological significance. There's certain places, certainly places where we've destroyed it, but every square inch of the planet has ecological significance. Even our yards, even our corporate landscapes, even our roadsides. So what we need to do is put the plants back. We need to glue our rug back together again, using primarily those keystone plants, the ones that are going to support the most life. After we've got them in there, we can diversify. Where are we going to put them? In between those fragments. That's where you and I live. It's where we work. To a lesser extent, where we farm, we need to not only create biological corridors that allow the plants and animals to move back and forth between habitat. We need to make these areas so rich they're going to live there. This is going to be viable habitat, which means we're going to share our spaces. Our third misstep was to leave Earth stewardship to just a few specialists. We didn't see it as an inherent responsibility of every human being. But I have no idea why. Every human being, every person on the planet depends entirely on the quality of Earth's ecosystem. So why wouldn't everybody have the responsibility for good Earth stewardship? No idea. Stan Rushworth, the Cherokee elder, once said that the Western settler mindset was, I have rights. The mindset of indigenous people is, I have obligations. You're not born with these mindsets, you're taught them. We're good at teaching this. We've been terrible at teaching the obligations that we all have for our nest, for our Earth. It doesn't mean you have to save biodiversity for a living, although it's a good living, but you can save it where you live. I like this approach because it empowers each one of us. A lot of people feel powerless today. One person cannot make a difference. The Earth's problems are so huge. They are huge, but one person can make a difference. Go out and plant that oak, plant a black cherry, plant any one of the powerhouse plants. Put in a pollinator garden, shrink your lawn, get rid of your invasive species. One person can do that. And all of a sudden you are an important cog in the wheel of conservation. It also shrinks the problem down to something that's manageable for each one of us. Don't worry about the entire planet, just worry about the piece of the Earth that you can influence. If you own land, it's certainly the land that you own. And if everybody who owned land did these things, we'd be 85% done. If you don't own land, you can volunteer, help somebody who does, help a land conservancy, help them manage their properties, or the local park or preserve near you. They all need your help. So as property owners or as volunteers, each one of us has the power. We certainly have the responsibility to fix dead landscapes like this. Whether or not we determine or decide we're going to do that is going to determine nature's fate, and then ultimately our own fate. I've convinced my grandchildren that you are nature's best hope. I hope I've convinced you as well. Thanks very much. I will see you shortly in the water cooler room.
Thank you so much, Doug. You packed so much information into that, and I'm certain we've all are coming away from this with steps that we can take now, today, at home and in our communities. So as Doug said, now is the time to head to the water cooler. That link has been posted in the chat. We will reconvene at 2:45 for a very special session with Nicole Manieri, timely as well, rhythm, song, and community healing. So see you at 2:45, and thanks again, Doug.
You're welcome.